I'm going to show you the easiest way to learn Python. For that, we're going to use the Raspberry Pi and the Thonny Python editor included in the Raspberry Pi. So I have my Thonny editor here, and the way I'm going to show you how to learn Python, it's using the Turtle module. So Turtle is one of those modules or libraries that comes with the Python install. You can go online and find the documentation for it. And here they call it Turtle graphics, and that's the main reason why we're using Turtle. Turtle allows you to draw graphics in Python, which makes it easy to understand what your code is doing. This is an example of what can be done with Turtle. So I'm going to walk you through how to get Turtle started in your program, and then we'll learn some Python commands. So you pretty much you don't have any to have any knowledge of Python to get started with this. Just follow along with me. You can type with it, pause your program, and test it out. So we have import turtle is going to be the first command that we're going to run. Now, when I run this, it's going to ask me to save it. So I'm just going to give it a name. I'm going to call it turtle01. Don't call it turtle. If you do that, you're going to get a warning saying because the name of the turtle is the same name as the module, it might cause some conflicts. So you might see these errors. So I'm going to say no. I'm going to say turtle 01. Good. So now we have import turtle. When I run the code, you can see nothing really happens. So the first thing we're going to do is we're going to use the turtle. So I'm going to create a variable, an object. It's going to be Shelly. I'm going to create Shelly, and then here I'm going to use turtle dot uppercase turtle parentheses. So when I run this, you can see that now we have a graphical interface. So this graphical interface, it's what is so powerful about Turtle, is that it can visualize your code essentially. So that way you can start making sense from the code that you write just by looking at the results. I found this to be a very effective way to teach Python and obviously to learn as well. Okay, so I'm going to close this. So what can we do with Turtle? So Turtle, it's essentially it's a pen, and then you see the shape of the turtle, so you can see where the turtle is. So I am going to say, Shelly, go forward 100 pixels. A pixel, it's essentially a dot on your screen. So it went ahead and moved 100, and you can see forward means that it was pointing here in the middle of the screen, is pointing forward, so it moves forward 100 pixels. Then I am going to turn left. So to do that, I am going to go to the documentation here, and we see there's a forward command here, but also there's going to be left. So if I click on left, there's two options to the left, or LT, and then it has a parameter. That's what's called what's inside the parenthesis here. It says parameters is angle, which is a number. So what this method or function do is turn turtle left by angle units. So whatever units you put in here, the turtle is going to turn left. So let's test this out. If I go here, you saw that it went really quickly. There's a way to slow it down. Let's see if we can find a speed function here. So I'm showing you how to go through the documentation so you understand the commands that are available to you. That way you don't find yourself trying to guess them. So I can do speed. So it says speed is between 0 and 10, or a speed string, meaning that you can put a word there. So you can say the fastest, which is 0, fast is 10, normal is 6, slow is 3, slowest is 1. So once you create the turtle, you can say Shelly. You can type speed, and the options are either a number, so 0, 10, 6, sorry, a number between 0 and 10. Basically, anything above 10 is equivalent to 0, which is the fastest. So you can say fastest, and then we run that. So you saw that it was almost immediate. It's going to depend on your computer. Or I can say, what are the other options? So we have fast, normal, slow, and slowest. Let's see what normal looks like. So that's normal. And then let's see what slow looks like. And then slowest. So you can see that that's the it changes speed, right? So we're going to change to slowest, and that way you can see what's doing. So if I run this, you can see it's going forward, and then it rotates. So it was going this way, and then it rotated around this way. Now it's pointing up. So if I now do Shelly, I go forward again another 100 steps, and then Shelly, because I know what's going on here. So I say Shelly left. So let's see what's happening. So it turns, and now it's pointing this way. So the reason why turtle is so powerful is because I can, I'm starting to train my brain to think the way a computer thinks, and this helps me correct any wrong assumptions that I may have. So for instance, if instead of turning left here, I turn right. Sorry, I turn left here, so that's fine. But if I turn right on the next one, let's see what that looks like. So that's going to look like, so you can see where the arrow is pointing to, where the turtle is pointing to. So you know that if you move forward now, then it goes that way, turns right. Okay, so now we have more of a staircase. I wanted to draw a square. So how do I draw a square? So you go back to your code, and then you compare it to what you see on the screen. So we have forward, left, forward, right, forward. So now, as you can see, you can read the code and you can visualize it. But let's say we wanted to draw a square. So some people may, and I've seen this, so different people think of different ways. So and that's perfectly fine. So I've seen cases where people will go this way, they go up, then they turn right, and then to fix this, instead of turning left, which is what I would do, in this case, maybe they go backwards. When you run this forward, so that's a different way to tackle the same problem, and that's what coding is about. It's about problem solving. And then in this case, now you can either do Shelly. You can turn right again, or you can turn left. Let's see what that does. So the beauty of this is that, as you can see, you're creating yourself some problems, and then you're fixing them out on the way, which is what the main goal here is. And then Shelly, backward again. So it's essentially similar to driving a car. You'll be driving here, you turn this way, you turn that. So I drew a square, which is the ultimate goal, and maybe I don't care how the square was drawn, right? So this is one way, and this is what if when you look at the code, you see the results and say, okay, this is what I was looking for, so this is good enough. Now, for the purpose of this class, I am going to change everything to forward left, so it's less confusing. But I just wanted to illustrate that you can actually solve the same problem with a different approach. And that's what life is about. So coding allows you to improve your problem solving skills. So we have now forward, left, and see, I left it backward there, so now it's wrong. So let's fix that. So forward, left 90, forward, left, forward 190, left, and then forward 100, then left, and then backward 100. So it was pointing down, and I went backward, so I need to go forward instead. So visually, it's easier to find our mistakes than when that we're not doing the visual programming here. And you probably noticed that I added an extra Shelly left here. If I remove that, we still have the square, which is fine. But there's a reason why I added that left 90 there, because first of all, I wanted to end the same way that I started. So when you look at the program when it starts on the horizontal, and then pointing towards the right, and it ends vertically pointing down. So I don't want that to be the case. And it's also to illustrate the next point. Okay, so now we have our square. So if you've been paying attention, you probably notice here that there's repetition, right? This is why I'm using the forward, left, forward, left, forward, left, forward, left. So what do we do when we have repetition? So this is one of the problems with having this code repeat is that if I wanted to change the size of the square and I want it to be 150, if I change it on 1, then it's no longer a square. So I need to correct that, and all of them needs to be 150. So one change needs to be always made 4 times. So how do we improve on this? So what we can do is we'll take this. This is the pattern because that is repeating, and that's all we need. And we need to find a way to repeat that pattern 4 times. So luckily for us, we have something called a for loop in Python. So the syntax for the for loop is you say the word for, and you can see how it's highlighting in a different color here because it's one of the reserved keywords. Python has about 30 of these keywords, the same way that you see with import here. Okay, so we have for, and then you'll give it a variable name. So you can say for side in range for colon. All right. So what do we do here? So there's a lot going on. So I have for side in range 4. So range 4, it's essentially a counter mainly designed for loops, and it counts up to that number. So you can count from 0 to 3, and it gives you four numbers or four iterations for your loop. So we have every time that so the way the loop works is that okay, I'm going to count up. This is my maximum is going to be 3, or actually 4. Sorry, I'm going to do 4 iterations, and then on each iteration, I'm going to run this block of code. How do I know this is a block of code or a code block? It's because I have a colon in here. This is a Python uh, creates block codes. You provide a colon, and then you use blank space, essentially a tab, which is 4 spaces, 1, 2, 3, 4, 1, 2, 3, 4. Everything that is on the same indentation, which is the space between the margin and the beginning of the line, it's the indented into the same block of code. So when I run this, essentially what this is going to do is going to count up to this number 4, and it's going to repeat this code this many times. So it's going to repeat it once, and then 2, and 3, and 4. And once it's done, it's going to move over to the next line down. So the way Python will interpret this is going to import turtle. It's going to create a variable called Shelly with the assignment. Then it's going to create this using this object. It's going to set the speed of this object to slowest. And then it's going to run this, whatever's inside here, 4 times. So it's going to do forward once, left once, goes back up in the next iteration, and so on. So let's see if that's true. So I run my code, and exactly the same results that we had before. It ends pointing to the right with the 90-degree change at the end, and it drew a square. So this is great because now if I wanted to change the size like we did before, all we have to do is change it here, and that's it because it's repeated. So the change once, and then it runs with a change for every iteration. So you say, well, that's not a big deal. It's I don't mind changing something 4 times. So it doesn't seem like a lot of work, and you're probably right. But when you have that many times in your code, it's also prone to errors because you might forget to change one. After a while, when you're looking at your code, everything's starting to look the same. If you try to read, sometimes you write your own documents, and you proofread them, read them over and over, and then there's some mistakes that you don't see because you're so into it. So it's better to have clean code that you can maintain easily. And also, when you're writing code, you need to think about who the code is for. So the end result, the product, it's for your users of this application. but the code it's for developers. So it'll be for you, for your team, anybody that is going to pick this up in the future. So if you write it really clearly and sort of coming up with good names, then it's going to make it easier for everybody. So for maintenance purpose, this is why you want to start using this sort of approach. All right, so this is a for loop. Basically, what we did is we had you know two lines of code repeated 4 times, and then we abstracted into something more compact, more reusable, right? Because now I can use this code in an easier way. So if I run it here, make sure that it's still working. Okay, good. So now I can expand on this and I can say, okay, so I have a square, but what about a pentagon, right? So a pentagon is 5 sides. And do you think this is enough if I change it just to 5? So it's going to do 1, 2, 3, 4, 5 sides, but it still looks like a square. The reason for that is because we didn't change the angle. So the other number here that it matters, it's the angle. So you need to figure out what this angle is going to be. The nice thing about Visual Code is that you can do trial and error. So you start with 90, and then it's either above 90 or below 90. So we'll see. Let's see if it's 100. So we see that if it's larger than 190, then it actually closes the angle and the shape is not what we wanted. So if you think in terms of what a pentagon would look like, it would be this way. Then instead of going straight up for a square, it would actually go maybe to this side. So instead of 100, which is adding 10 to 90, let's subtract 10 from 90. So now that's going to turn left 80. So this is looking better, but we missed it, right? So it's somewhere. So it's below 90, but how much below 90 is it? So obviously this is a time-consuming approach. So it looks like we got really close to it, right? So it's between 70, because if you remember, 80, actually, I'm going to change this to as. If I change this to 80, then we way past the closing point. If I went to 70, we didn't quite reach the closing point. So we know that it's somewhere in between. If you do 75, I am going to miss I'm going to actually go over the point as well. So it's between 70 and 75. You can continue to try to do this. You'll find that the actual result is 72. So that is one way to approach this. And then let's say, okay, how about a hexagon, right? So then hexagon, so we see the pattern. As we get into a higher number of sides, we are going to move into a slower number. So I'm going to try my lucky 60. So hexagon is actually 60. And if I do, heptagon 7, then what? So you need to do this calculation. So why don't we use the power of Python to help us out with this? So if I go here to my console, to the shell allows me to type Python commands in here, and then I get an instant response from it. One of the operators that we have in Python, we have math operators. We have plus, minus, division, and multiplication. So if I wanted to multiply 2 times 2, it should give me 4 right away. Do it correctly. 2 times 2, 4. All right. So what I'm trying to get to here is that, so let's start with 4 and 90, right? So what's the relationship between 4 and 90? So we know that there's 4 sides, and if I multiply 4 times 90, I get 360. So that's a family number, because that's the entire, the number of degrees that represent the circle, right? So, and we did 5 and 72. So what happens if I multiply 5 times 72? It's 360 again. So we see that there's a connection between 360 and then divided by the number of sides. That gives you the angle that you're looking for. So very quickly I can find out, what the angle is. So for 7, it's going to be 51.42. So you don't want to be writing that whole number. So essentially, the best way to do is, because let's say for 7, it is 51. So it looks almost there, but it's not. So there's a decimal point, and that's because every one angle, it's going to keep you further away or further, or make you go over. So it needs to be exact. So what we're going to do is we're going to have 360 divided by 7. And then when I do that, I had the shape that we wanted to do. So again, I'm repeating myself here, so let's fix that with our code, right? So in Python and programming in general, when you see something that is repeating, you can probably tackle it again, because if you say, hey, I'm going to do the pentagon again, and then you forget to change this, then you have what is called a bug in your code, right? So the code works fine, but it's more of a logic issue. That means your calculation is off. So then you have to go back to your code. It's like, what is going on here? So okay, here it is. I forgot this. Easy fix again, but they're not easy to find when you have a lot of lines of code and be working on this for a while. Okay, so so how do we prevent this from happening? So we're going to use something called a variable, and the variable I'm going to call size. So the size is equals to 5. A variable is, you see an equal sign here. When you saw me using operators here, I didn't use the equal as a math operator, because equal is actually an assignment operator. So what that means is that equal, it's going to take this piece of data, which is a number in this case, and it's going to assign a label to it. And that's where the assign part comes from. So we take 5, we record that 5, we remember that 5, and this 5 has a sticker attached to it called size. So in the rest of my code, I can refer to that sticker or variable, and it gets replaced every time. So when I do sides, just to demonstrate that it's still working, so we have sides, so it should go 5, 1, 2, 3, 4, 5, and then it's going to calculate the angle automatically. So sides, so if I now create an octagon, I can do this very easily, right? So now I'm getting quicker at just with one small change, I can draw the shapes of any closed polygons that I want. So I go from 3 to all the way up to however many sides. So let's see what happens when we do 25. So you can see it's starting to look like a circle, and that's essentially, so if you imagine, it goes triangle and then square and then pentagon, it starts closing into more of a circle shape. You also notice here, because we have so many sides, is that it's getting quite large. So we can control that with the length of the side. So let's say for a circle, I want to use 20 instead of 100. Let's see if that's better. Yeah, so that one fits better. But obviously, if I now do a square, it might be too small. So now it's a tiny square. So then I need to change this again in my code to maybe 100. So again, you can use here a variable. So let's call this side length. I'm going to call that 100. And I'm going to take this name and I'm going to replace it here. So what I'm doing is, again, abstracting what's inside a particular set of lines of code here, because I'm changing them over and over. Then I'm going to extract them from here. I'm going to give it a variable name. So again, I define a data number here. I assign a label to that number. And in this case, as you can see, when you create variable names, it's important to use names that are meaningful. I could have used S for this and SL for this. And you see that in a lot of code, then I have to use S here and S here and SL here. If you look at this now, you are within the context that we just talked about, which is like size and side length. And you remember what those single letter variables mean. However, probably in 3 days, a week, or 2 weeks, next month, you're going to look at your code and you will have to refresh your memory. What were you talking about when you said S? And maybe you're using S multiple times because S can refer also to speed, right? Or it can refer to something else. So you're asking your brain to work a little bit harder just to remember what that variable is. And why? Because you didn't want to type an extra few letters. So I recommend that you use meaningful names. Try to keep them all lowercase. It's not a requirement. It's a guidance that you should follow. And uppercase names are usually used for something else called a constant, which is still a variable, but it's a variable that really doesn't really change in your code. Maybe the size of your window, the screen, or a particular color. You have it defined to something. So keep it to lowercase. There's no spaces allowed. So there's a couple of rules for you to remember. No spaces allowed. So I use something you can visually separate the word by using something like the underscore. There's another approach which is using what is called camel case, where you introduce a capital letter here, and then visually you can see both words. I like using space with underscores here. And then you kind of use existing keywords. So for or import are not valid variable names. If you try to use these, it's going to run into some sort of error here. So do not use reserved words. And lastly, you cannot start with a digit. So one variable is not a valid number. And you can see here that it's not going to take it. So it says, let me expand this. I see the error message better. So one variable is invalid syntax. This is Python telling you, I don't know what you're referring to here. So what you're going to do is not use numbers as a starting. You can use a number. You can say sites 45, 6, 7 equals to 23. So you can add numbers inside the variable name, but not at the beginning. And that's essentially everything you need to know about variables for our purpose here. So as you can see, I'm taking advantage of that. There's one more variable that I can come up with. I don't know if you can see it here. So I still have a number in here and I have a calculation. So I am going to define the angle, and then it's equals to this number, 360, divided by this variable size, right? So, and then all I have to do is replace this here. So the reason I'm doing this is because now I can read my code. So if I'm, if I find this program and if I've never seen it before, I go start reading. It's like, okay, it looks like it's importing turtle. It created a turtle called Shelly. Okay, Shelly has a speed, it's fast. There's something with sides. There's a length side, an angle, which is related to the number of sides. And then it's a repeated, so it's a for loop. So it's going to repeat this a number of sides. It's going to move forward the length of the side, and it's going to turn the angle every time. So without explaining a lot in my code, somebody can come in here, read, and understand what the code is going to do. So if I say 7 sides, then I know that it's going to draw something with 7 sides. What does it look like? We'll just run it, and that's it. Very good. 9 sides, and so on, right? 3 sides. Then just out of curiosity, if you do 2 sides, that's essentially a straight line, goes back and forth. Let me slow it down. Turns around and it goes back and forth and stays there. And if you do one side, what happens? Just one side and then 360 degrees at the end. So it still works. Your code still works, but it doesn't draw a polygon because it's not possible to do one or two side polygon. So we start at 3. So we have, we'll do the 4 that we had before. So you can see we started with, I want to draw a square, and now I have a program with about 10 lines of code that can draw pretty much any polygon that I want very, very easily. So good job. We'll continue working with Turtle. so you can get improving and continue improving your Python skills. Thanks.